Hello guys, let's solve this rather confusing differential equation right here, and I've also given you guys a hint right here. So if you want to solve this on your own, please pause the video and I'm going to start it in 3, 2, 1. So this hint right here, I've underlined the word straight because another word for straight is linear. This differential equation is in fact in the linear form. Now, if this t was an x, you would see that this all of these terms would be x, and simply by moving the x there, we could turn it into a variable separation method and continue. But this t gives us a little problem. So let's do something about that. I see we have a fraction over here, and that I can also split these fractions into this minus that. So I'll just do that in the next step. E to the power tan inverse of x by 1 plus x square minus t by 1 plus x square. Now, for a differential equation to be in a form, or the linear form I mean, we should have, let's say, dy by dx plus py equals to q, where p is the function of x and q is the function of x or any constant. So instead of y we have a t, and if we move that here, we can see we'll have dt by dx plus t 1 plus x square is equals to e to the power tan inverse of x by 1 plus x square. So this is in fact in the terms of that, because instead of y we just have t and our p right here. If we just put this as 1 and multiply it with t, we can compare these two and see that p is just 1 by 1 plus x square and q is this part over here. So we have successfully put this in a linear form. Now all we need is our integrating factor. So integrating factor mu, this is equals to e to the power integration of p with respect to dx, or multiplied by dx. So this is just e to the power, here our p is 1 by 1 plus x square into dx. So we have to figure out the integration of 1 by 1 plus x square dx. But I think we all know what this integration is. Or if you don't know, simply this is the integration of, sorry, this is not the integration. This is the derivative of tan inverse x, which means that in inverse, the integration of this gives tan inverse x. And if you want to know how, just substitute x as tan theta and you can continue from there and you'll get tan inverse x, but it should be plus c. But right here we don't in fact need plus c over here, because this will give us e to the power tan inverse of x plus, if we do plus c, we'll just have e to the power c. And the fact is we have to multiply the integrating factor to both of these terms right here, meaning that simply that e to the power whatever that constant will be, we can just divide them on the next step. So this is e to the power tan inverse of x. Now another reason we need to find the integrating factor is because if we multiply integrating factor in both of these sides, this differential equation will turn into the the exact form, and we can continue from there. We continue from here when we multiply the integrating factor to both sides. So we'll get, here I'm just going to distribute them. We'll have e to the power tan inverse dt by dx plus e to the power tan inverse of x 1 plus x square into t is equals to e to the power tan inverse of x into e to the power tan inverse of x by 1 plus x square. So this might look confusing over here, but the fact is this will always be in the exact form. And right here, let's just multiply everything by dx. So it will be like this, and I've kept it like e to the power tan inverse x into e to the power tan inverse x, because sometimes when solving differential equations, you just have to see what the derivative of that might be, which will be useful in the future. So for e to the power tan inverse x, its derivative is e to the power tan inverse x by 1 plus x square. So we might need that for some kind of substitution. And right over here, this is in fact the derivative of, well, you can see in the first term, we have e to the power 10 inverse x, and we differentiated respect to dt, and we just got dt. So that means we have a t right over here, only a t, multiplied by, well, it is like if we had done a product rule on two variables. And from here we can see that the other one is e to the power 10 inverse of x, and if you differentiate that, you'll get this part plus t into the derivative of this, which is e to the power 10 inverse x, by 1 plus x square due to the chain rule and with respect to dx. And this will be this part over here. So we can simply integrate both sides right here. And from the principles of calculus, the integration and derivative will cancel. So on the left hand side we have this, and over here I talked earlier how the derivative of this was that, and I talked about some kind of substitution. Well, if you substitute, let's say e to the power 10 inverse x as u, what I'll have is u into its derivative is just this part over here, as I said earlier, as I said over here, as I said over there. So like u into du, integration of that, and this is just u square by 2, and here now we need a constant plus, let's just say plus c. We can change this constant to however we want to make the final answer nicer, but let's just choose c for now. And here we'll have u square by 2, but our u is in fact this over here, or to be more specific, that over there, but doesn't really matter. So we'll have e to the power 10 inverse of x whole square by 2 plus c. Now you can leave it as that, but to make this separate, to make this t isolated, what I can do is I can divide both sides with respect to e to the power 10 inverse of x. So here I'll have e to the power 10 inverse square by e to the power 10 inverse x. So simply the square and that will cancel, giving us e to the power 10 inverse of x by 2 plus c by e to the power 10 inverse of x. Now I also have kind of a shortcut for you guys. So as I said earlier, when you multiply the integrating factor to both sides, this will become my exact form. But the thing is, you have to observe what the exact form will be, what will the derivative will be, such that you can integrate and cancel them. Well, there's a trick. Let's say this was your the linear form that you had, and this was your integrating factor. Well, directly in the next step, you can say that the variable t, or sometimes y, or whatever is in top of the dx, ds by dx, then it will be s. This will be t into the integrating factor is equals to the integration of q into dx. So earlier our q was this part over here and p was this. So we would have t e to the power 10 inverse of x is equals to here q, this should be q into the integrating factor dx. Just remember that, and it would be the same thing. We would have this as it is multiplied by e to the power 10 inverse x and dx. And as you can see, this and this is the same, because here when you integrate and differentiate that, they just cancel each other. So essentially you just have this part is equals to this part, which is this. And just a little shortcut for saving times, because we mathematicians are lazy. So if you guys learned something new, please like and subscribe. Thank you.